You know that feeling when you look up at a clear night sky? That sense of just, wow. You feel like you're part of something absolutely immense, right? Well, today, we're going to try and get a handle on that feeling. We're going to explore the true, mind-boggling scale of our universe.
So let's just dive right in and ask the biggest question there is. Just how big and how old is all of this? I mean, everything. It's a journey to the very edge of what we can even comprehend, and it's going to start right here, right now.
Okay, so to even start to wrap our heads around the universe, we've got to know where we are. It's kind of like trying to read a giant map. First thing you do, you find that little "you are here" dot.
And for us, that "you are here" dot is home. Planet Earth. This beautiful, familiar blue marble. This is our starting line. The one place we know best.
But okay, let's pull back just a little. Earth isn't floating out there all by itself, right? Nope. It's just one planet in a whole family orbiting our star, the Sun. So already, our home is becoming just one little piece of a much bigger system.
All right, let's keep going. Zoom out even further. That entire solar system, the Sun, Earth, all the other planets, is nothing more than a tiny, tiny speck of dust inside our home galaxy, the Milky Way. A galaxy that's packed with hundreds of billions of other stars.
And here, this is where your brain might start to hurt a little. You ready? Our massive Milky Way galaxy, it's just one of at least 100 billion other galaxies that we can see. Just let that number sink in. 100 billion galaxies, and each one is filled with billions, sometimes trillions of its own stars. Yeah, the scale is, well, it's pretty much impossible to really imagine. So, okay, when you're dealing with distances that are just that insane, how do you even measure them? I mean, miles or kilometers? They become totally useless. We're going to need a much, much bigger ruler, a cosmic ruler. And that ruler is the light year. Now, this is super important. It's not a measure of time, even though it has year in the name. It's a measure of distance. It's how far a beam of light can travel in one single year.
And just to give you an idea of what that means, light is the ultimate speedster, the fastest thing in the entire universe. It zips along at an incredible 186,000 miles per second. So, a light year is a ridiculously huge distance. We're talking nearly 6 trillion miles.
So let's put this new cosmic ruler to the test, shall we? Let's see how it works. A beam of light from our moon, it gets to us in less than 2 seconds. Zap. From the sun, a bit of a longer trip, about 8 minutes. But to get from one side of our own Milky Way galaxy to the other, that same beam of light would have to travel for 100,000 years. And to get to our closest galactic neighbor, Andromeda, hold on. It's a 2.5 million year journey.
Okay, so now that we have this cosmic ruler, what's the grand total? How big is the whole shebang? Well, the part of the universe we can see, what we call the observable universe, is estimated to be about 93 billion light years across. Yeah, 93 billion. Just take a second. Let that number land.
Wait a second. I know what you're thinking, because I thought it too. How does that work? If the universe is only 13.8 billion years old, and nothing can travel faster than light, shouldn't it be, 13.8 billion light years across at most? How do we get to 93 billion? It's a fantastic question, and the answer is one of the wildest things about our universe.
Here's the secret. It's because space itself is expanding. Think about it like this. Take a balloon and draw 2 little dots on it. Now start blowing it up. The dots are getting further apart, right? But they're not crawling across the balloon's surface. The rubber of the balloon itself is stretching, carrying them apart. That's our universe. And here's the kicker. While stuff in space can't break the speed of light, the expansion of space itself doesn't have a speed limit. It can stretch faster than light. That's how 2 galaxies that started out much closer together can now be 93 billion light years apart.
All right, so we've kind of wrestled with how big. Now let's tackle how old. And to figure that out, scientists basically have to become cosmic detectives. They're looking for ancient clues, little breadcrumbs left over from the very beginning of time itself.
And after years and years of piecing all this evidence together, the best estimate we've got for the age of our universe is 13.8 billion years, an almost incomprehensibly long time.
But hold on, that's a pretty bold claim, right? I mean, how can anyone possibly know that? How can you put such a precise number on the birthday of, well, everything? It all comes down to a few key pieces of evidence that all point to the same conclusion.
So, the cosmic detectives have 3 main clues.
Clue number 1, looking deep into space is like looking back in time. Seriously, the light from a super distant galaxy might have taken billions of years to reach our telescopes, so we're literally seeing that galaxy as it was when it was just a baby. Clue number 2, we can measure how fast the universe is expanding. And if you know it's expanding, you can hit the rewind button on that expansion, calculating all the way back to when everything must have been crunched together in a single point. And clue number 3, this one is amazing, we can actually see the leftover heat, the afterglow from the Big Bang itself. It's called the cosmic microwave background, and it's basically the universe's first baby picture. Put all 3 clues together and boom, 13.8 billion years.
Okay, so we've talked about this vast, vast size and this incredible ancient age. It's mind-blowing, but it leaves us with one last, kind of personal question. Where do we fit into this epic story?
And this is maybe the best way to visualize it. Imagine you squish the entire 13.8 billion year history of the universe down into a single calendar year. So the Big Bang happens at the stroke of midnight on January 1st. Our own galaxy, the Milky Way, it doesn't even start to form until mid-March. Our Sun and Earth, they're late to the party, not showing up until early September. The dinosaurs, they first appear super late on December 26th. And us, humans,
We show up at 11:59 p.m. on December 31st. We exist in the last minute of the last day of the cosmic year. Think about that. Every single thing we call recorded history, every pyramid, every empire, every war, every discovery, every song ever written, all of that happens in the last few seconds before the New Year's bell rings.
So, let's just take a breath and recap this incredible journey. The universe is literally everything. All of space, all of time, all matter, all energy. It's at least 93 billion light years across, and it's getting bigger every second. It all kicked off about 13.8 billion years ago. And all of human history? Well, it's just a tiny, fleeting flash in that immense timeline. You know, hearing all this, it might be easy to feel, well, small, insignificant. But I like to think of it the other way. It doesn't make us small. It makes us part of something absolutely jaw-droppingly amazing. The fact that we, these beings who've only been around for a few cosmic seconds, can piece together this story, that's incredible.
And it leaves us with one last, huge, tantalizing question. Remember, our observable universe is just the part where the light has had enough time to reach us since the Big Bang. So the biggest question of all might just be, what lies beyond that horizon? What's out there, just past the edge of what we can see? The story, you realize, is far from over.